Hey, I'm going to try and explain why we use angle of inclination in this question to find a certain angle, theta, that we're going to construct now. Cool. So in this question, we're actually going to construct a parallel line to the x-axis. Cool. So that's parallel to the x-axis. And we call this angle theta here. So as part of our calculation for a specific question, we were actually wanting to find this angle theta here. And in the video, we see that we actually used tan theta equals 1. Okay, so where did that come from? How do we use that? I'm going to try to explain it now. Cool. So the whole idea here is something called angle of inclination. Inclination. And what this says is that if you take the tan of an angle, some angle, let's call it theta, that is equal to the gradient of a line, of a straight line, but not just any straight line, it's got to be very specific. And what is it? It's a straight line such that it is going through the x-axis here, and it's a positive orientation from the x-axis. So what I mean by that, I mean that when we measure the angle, we measure it counterclockwise. So that angle theta there. But that angle theta is actually the same as this angle theta here. And why is that true? Because of alternate angles. Okay, so that's how we get theta here. And then how did we get this tan theta equals 1 here, and why did we use it? So remember, the gradient of this line, which is actually tan theta equals gradient of AB, this line AB here. And how do I find the gradient of line AB? Remember, the formula for gradient is rise over run. Change in y over the change in x. What is the change in y here? It goes from the y coordinate 9 to the y coordinate 2. So we've moved down a total distance of 7. And then what is the change in x here? From this coordinate 3 to that coordinate negative 4, do you agree we've also changed a total distance of 7? So the gradient of line AB is change in y divided by the change in x, which is 7 divided by 7, which is positive 1. And how do I know it's positive as well? Because you see, this line here is increasing. It's increasing from left to right. Right? So that's how I know that this gradient is also positive. Now, the formula says that tan of the angle must give you the gradient of the line AB, so that's 1. Okay, so that's how we actually get this one here. And then how do I find theta? Well, that's a special angle. Tan of what gives you 1? It is 45 degrees. So that is theta, 45 degrees. Just as a quick addition, why do we actually use this formula here? Well, remember when you do tan of an angle, when you have your nice diagram here, let's call that theta. Let's call that point there xy. So then this distance here is y, that distance is x. And remember, tan theta is what? Opposite over adjacent, which is y over x. But that is also gradient, right? Y over x. That's exactly what we've done here. So that is why we actually use this formula over here. Cool. I hope this helps.